Okay. All right. Cool.
All right. Tom Bliss.
All right. Thank you, everyone, for joining. Thank you, everyone here in person. Thank you, everyone online. Thanks to my friends and family who are joining. I want to first say thank you to my mom. She is up at 6 a.m. in California watching this. So thanks, Mom. Thanks, Mom. Yeah. All right. Yeah. Round of applause to Mom. All right. So I'm here to talk about rest advantages in the NFL and how the different sort of differences in days off may affect game outcomes. So to start, I'm going to give a quick refresher on how the NFL schedule works. There are 272 games in today's NFL. Before, there were only 256, 16 per team, 32 teams. The NFL schedule is built up of matchups between two teams that are in each of the team's home and away stadiums. What the matchups are and who's home and who's away, that's determined by a rotation system, as well as like the previous season's results. So, for example, if you asked me what the Steelers' opponents were in 2036, assuming there's no changes to the schedule process, I can tell you 14 out of 17 of those, and the other 3 will be determined by 2035 results. So, to be clear, the majority, like all of that, is simply determined by a rotation system that's agreed upon on the CBA. The other sort of component of the schedule might be the order of the games and the timing. That is decided by the NFL scheduling team. So whether or not this team plays Monday night, whether or not this team has 3 games on the road in a row, that's determined by the scheduling team. And building this schedule requires a huge optimization problem. If you think about 272 games that you could put in about 5 slots each NFL week, and there's 18 NFL weeks, that creates a lot of options. So just to sort of note that this is a huge optimization problem that we're trying to solve. All right, so game timing. So NFL games, for those of you who follow, you might know that the majority of NFL games are played at either 1 p.m. or 4 p.m. on a Sunday. Other NFL games, you'll sometimes be playing Monday Night Football, Sunday Night Football. These are what I would call primetime games. These are examples of games in which you might try to highlight the better or more popular teams. These games are not sort of distributed randomly across all teams. Like if you're a better team, you're more likely to be playing in Monday Night Football because of just how, or if you're perceived as a better team by the NFL schedule makers prior to the season, you're more likely to play just because of how the schedule works. The other thing I'm going to add is additionally, each team will have 1 bye week, 1 off week per season. That's a week in which they don't practice. They don't practice in today's NFL, and they don't play any games. But the thing I'll note about the CBA is prior to 2011, players would be practicing during that bye week. The collective bargaining agreement agreed upon between the NFL and the NFLPA made it eliminated practice time for NFL players during bye weeks. The reason they did that was the NFLPA wanted the bye week to be a true off week. So prior to 2011, players were, during their off week, they were getting extra time to prepare for their opponent. Now they're not practicing at all during that week. And finally, I'm going to talk about rest differential. So that's kind of the key metric that we're going to be talking about here. So you can think about rest differential. That's the difference in preparation time or rest time between 2 teams that meet on the same day. So for example, if one team had an off week and another team didn't have an off week, the team with the off week would have had more days of rest. And that's kind of what we're going to be talking about during this presentation. So the key question here is, does rest differential affect game outcomes? I put together this chart above that shows the Titans at the top in terms of their rest differential sort of disadvantages. They appear to have the most. San Francisco appears to have the least. And we can look at this graph and we can say, oh, this is unfair to San Francisco or too favorable to Tennessee. But the question is, what does this mean? Like having -3 bye, facing 3 teams off a bye, what does that actually mean in terms of game outcomes? And that's the question I'm going to try to answer. You can sort of complain about it, but what does it actually? How does that actually affect the games? So to do that, we're going to focus on 3 different advantages and kind of what we showed in the previous table. One will be what I'll call M&F advantage or Monday Night Football advantage. This is when your opponent has 6 days rest and you have at least 1 or more days of rest over them. The most common example is, you're playing on Sunday, your opponent's playing on Monday Night Football, then you meet the following Sunday. That gives you an MNF advantage. The next I'll talk about is mini-bye advantage. This is most typically after Thursday Night Football. Again, this is, imagine your team plays on Thursday, your opponent plays on Sunday, you meet the following Sunday. That means you have like 10 days off, your opponent has 7 days off. That is perceived as a potential rest advantage. And the final one is probably the easiest to explain, bye advantage. You didn't play the previous week, your opponent played the previous week, and now you're meeting. So that could have you have 13 or 14 additional days of rest compared to your opponent. So this is what we're going to focus on. So I'm going to memorize this because we're going to talk about this a decent amount. All right. So let's talk about the model. We are going to build a model, and we're going to think about 2 sort of outcome variables. One will be point differential. So one team's points scored minus the opponent's points scored. And the other one will be point spread, which is set by the betting market. And again, it's also on the point scale, and it's just a measure of difference in strength of the 2 teams. So these are the 2 sort of outcome metrics we're going to focus on when we build the model. In our model, we're going to include a variable for home advantage and team strength. These are both things that we don't necessarily care about in this analysis. We're not actually doing this analysis to get a value for home advantage or a value for team strength. We are doing that to account for things that we know affect the point differential and the point spread. Home advantage, we're using a linear effect based on some past research that Michael Lopez, and Luke Benz were involved with. And team strength, we have to include, as sort of I stated, certain teams are more likely to be on Monday night and Thursday night football than other teams. So we have to take that into account. And then the rest advantage indicators, that's really what we're most interested in. And we're going to include that in the model as a means to measure their effect. We're going to use data from 2002 to 2023. We picked 2002 just because that's when the Houston Texans became the 32nd franchise. So we have a constant number of 32 teams over that entire time period. We're going to use a Bayesian state space model in STAN, and I'm going to talk a little bit more about that on the next few slides. And I have my code right here, and I'll show it again at the end if anyone wants to check it out. All right, so this is an analytics conference, so we're going to have to show a little bit of math. So if you hate math, look away. All right, so this is how we're going to define our team strength. Team strength in season S for team I is a function of the previous season's team strength with an autoregressive parameter and some variation. To sort of talk through what that means, if you think about, let's say, you follow the 2023 season, and then you're on a desert island, and you don't see any of the offseason, and then you start watching 2024. You can probably make an assumption that the teams that were strong the previous season are also strong last season, and the teams that are weaker the previous season are also on the weaker side. So it's sort of a way to pass information from the previous season to the current season. Like, for example, the Chiefs won the most recent Super Bowl. I think most people are not surprised that the Chiefs are a strong team again this year. However, we have to include an autoregressive parameter. And by autoregressive, I mean bringing the teams all of them back to the mean. And that's sort of a function of the fact that the NFL has the draft, it has free agency, it has things that sort of bring teams, teams that were less successful the previous year up, and the teams that were more successful down. So this is just a way to, have a better team strength estimate by maintaining information from season to season. And this is a common approach for these type of models. All right, so this is sort of the main equation. I'm going to walk you through this slowly because there's a lot of stuff here. I'm going to start in the top left and then go left to right and then go into the bottom row. So this is the primary equation that we are sort of using. This is what we're fitting our models. On the top left, we have our outcome variable, and that's going to be either point differential or point strength or point spread, depending on what type of model we're fitting. Then we have our differences in team strengths. Again, we are doing this just to account for the fact that there are, we know that this difference exists. We're not necessarily interested in it, but we want to make sure we have the difference between the two teams playing. So that's why we have a term there. Then we have our home advantage. And again, everything in red is stuff that this model is solving for. These are unknowns. Everything not in the red box are things that we already know. Like we already know the point differential, the point spread. That's the outcome variable that we're solving for. And we don't know what the home advantage will be. We don't know what the team strengths will be. So then we have the Monday Night Football advantage. So the way you read this is alpha MNF, that is the coefficient that we are solving for. The indicator, I MNF, is sort of information on whether or not, when looking at that game, one of the teams had Monday Night Football advantage. And it's an indicator, yes, no, and it can be positive or negative depending if it's the home or the away team. The mini buy advantage works the exact same way as the MNF advantage. It's alpha is what we're sort of solving for, and then we have an indicator to sort of say whether or not the advantage was present for one of the teams and whether it was home or away. Then we have our two buy advantages here at the bottom. They work similarly to the other rest advantages in terms of how they're described, except for we add an additional term to sort of split the fact that we had a change in CBA. That is prior to 2010, we had the CBA in which during the bye week players were able to practice, and post 2011 we had the CBA where you're not allowed to practice. So we split these just to be able to measure these effects separately to see if this change in CBA had an effect on the bye week and how important it is to game outcomes such as point differential and point spread. All right, so let's go into some results. So I'm going to show you this team strength plot. Again, we're not interested in the team strength necessarily as a result, but we just want to use it to spot check to make sure our results make sense. So here are the team strengths for the AFC East from 2002 to 2023. We picked this division because I think a lot of people probably remember that the Patriots were the strongest team in that division for a pretty long period of time. However, recently the Buffalo Bills have been the strongest team in that division. If you look at the lines, they generally make sense. Last year, the Dolphins surpassed the Patriots. The Jets have sort of gone up and down a little bit throughout the years. So this is mostly to check to make sure the results make sense and they agree with our intuition, which I believe that they should with most of y'all. All right, so let's get into the rest results. So this is a graph that shows density plots of all the results. I'm going to walk you through it slowly because there's kind of a lot here. So first, I'm going to start out with the results on home advantage. And as a reminder, this is all point differential for this first part. I'm going to go into point spread later. This is all point differential. So the way you read this graph is it's a density chart. And unlike, let's say, a linear regression, these Bayesian state space models, they produce a multitude of estimates for each value. So instead of getting one single sort of coefficient value, we have a multitude of estimates here. And that's why we have a distribution as opposed to a single value on this is what we estimate the value for. It's a distribution of values. So we have home advantage right here. And as you can kind of see on the left, we have the percent greater than 0. That's the sort of percent it's positive. The fact that in both cases it's 100% positive, we can say this is a significant effect on point differential, which is not unexpected. We also have the median value for these distributions and the confidence interval. The median value in 2002 is about 2.8, and then it dropped to 1.7 in 2023. I think that agrees with intuition. Home advantage is significant, and it's dropping a bit. Now let's talk about the buy advantage. And this is probably one of the most interesting findings of this entire analysis right here. So if you look at the buy advantage from 2002 to 2010, you notice that the advantage was significant. And it's 99.6% is positive. The value is about 2.21, which is almost as much as home advantage. It's obviously a wider distribution because we have less observations. But the fact that it's significant and it's valued pretty high is pretty interesting. It's almost like an additional home advantage if you have that buy advantage. However, if you look at the buy advantage from 2011 to 2023, about 60% of it, 67% of it's positive. So, and the median's around 0.3. So it's significantly decreased in this new CBA, which is really interesting. So this would suggest that while the buy advantage was a significant effect from 2002 to 2010, it is not a significant effect today. I'm going to walk through mini buy and MNF as well. As you can see, the the percent positive is 80%. The value is around 0.48. This we would not deem significant based on sort of where this distribution is sort of placed. And with MNF, I would say the exact same thing. It's not significant. The median is pretty close to 0, and also the percent positive is pretty close to 50%. So we would suggest that the mini buy and MNF are not significant in point differential. In point differential, the only things that sort of stuck out as significant were the buy from 2002 to 2010 and home advantage. So that's an interesting finding. Now let's talk about point spread. Point spread, we have home advantage. We have home advantage from 2002 and 2023. The values are astonishingly similar to what we saw in point differential. I mean, maybe not astonishing. Maybe it's not unexpected that they're the same, but we are literally at 2.8 and 1.7 as we saw before, and the drop is basically the same. It's really interesting to see the fact that the point spread and the point differential, we fit a different model with a different outcome, and we're getting the exact same value for home advantage using this process. And again, these are still significant, and which would agree with our intuition that home advantage will affect the point spread. So buy advantage, again, is we have an interesting thing here. So unlike in point differential where the buy advantage decreased, in point spread, the value of the buy advantage increased in the 2011 to 2023 era, which is a little bit surprising. Both I would deem significant, although 2002 to 2010 is maybe right on the edge of being significant. And the median value for that is about 0.39, where the median value from 2011 to 2023 is about 0.97. So the value increased in today's NFL, which is a little bit surprising in terms of point spread. I'm going to get more into the comparison of point differential and point spread on the next slide or so. MNF advantage. In point spread, this was also significant, although the value was around 0.37, which is not particularly high. So that was also a little surprising that point spread was significant for MNF. And then mini buy, this was basically worth 0. So Thursday Night Football, both in point spread and point differentials, is insignificant and worth not many points, according to both point differential and point spread models. All right. So I'm going to do a little bit of a discussion on the two buy advantages and why we might have seen a difference in point differential and point spread, because I think that was one of the more interesting findings that we had. So right now you're looking at a box plot. The x-axis here we have our two eras. On the left we have 2010 to 2011 to 2002 to 2010, and then on the right we have 2011 to 2023. We have points added on the y-axis, and we sort of have the two distributions that we can compare here. If you look at the era 2002 to 2010, there's a much larger difference in the distributions than we see today. It is sort of surprising that there is such a big difference then, although it could have something to do with the volatility of the betting market back then. Our theory on why today we see a little bit of a difference is because we believe that as sort of point spread was sort of being calculated, specifically probably mostly in the early 2010s when there wasn't a lot of data in this new CBA, a lot of it was using information prior to 2010, which sort of brought the bye week up. If you were to fit a model without splitting it, on point differential, the value would be pretty similar to what you see in the point spread here. So we believe that when there wasn't a whole lot of data available to sort of fit a point spread model post CBA, they were unable. The model that the point spread was used to sort of work with was using a lot of data from 2002 to 2010. All right. So this is I'm going to have a few more sort of discussion points, and then I'll leave it for questions. So one feeling was the drop in the point differential suggests that it might. The reason why the bye week used to be value might be more of a function of the practice as opposed to the rest. And one thing I'll note is the NFL still has a postseason bye, and that's the best team in the league gets a postseason bye, and prior to 2021, it was actually the two best teams in the league, or 2020, get a postseason bye. So the postseason bye still has sort of a significant effect. You see higher win percentage and point differential in the more recent era for the postseason bye than you did in the previous era. So there is a belief, and during the postseason bye, you do practice, and it's more similar to the previous era's bye. So there is a belief that there isn't something else going on, the fact that the practice does still have a positive effect. And the other thing I'll note, obviously the NFL, as I've been sort of mentioning, these disadvantages are not distributed randomly across teams. They're not distributed evenly. The better teams are more likely to have these advantages or disadvantages. So we have to be, it is interesting, and it's good to see that this implies less of an impact of an imbalance by distributing these advantages and disadvantages. One limitation I have is I'm assuming team strengths are constant throughout a season. Obviously, if a significant player gets injured, a trade happens, a coach transitions, there could be some different effects within season, but I'm not taking that into account, but that's something arguably I should. Other variables such as travel, weather, I'm not taking into account here. And also, again, as I sort of noted, the volatility of the betting market might not be constant over this entire time period. So that's another thing that that this work may be limited by. All right. Thank you so much for listening. I have a QR code for the research paper that I have on this if anyone wants to read it. I also have the link right here. Thank you so much, and I'll open it for questions.
Raise your hand if you have any questions. I'll walk around with the microphone. All right.
Hey, thanks a lot. I thought it was a great presentation.
Thank you.
One question I had was if you considered multiple games as instead of just one game.
Yeah. So you're saying like a multiple game road trip, or like 3 games in 10 days, something like that?
Yeah, I would think that maybe the bye week would let you have less injuries and perform better over the next several games.
Yeah, we haven't looked at the effect per se on, like, let's say whether or not the bye week, maybe it doesn't help you in the following week, but it might affect, like if you look over a 3-game period following the bye week, maybe there could be a positive effect. We haven't looked into that. We have looked at using a similar analysis, things such as like a 3-game road trip or something like that. And we found similar results to this, but that's a good idea in the sense like maybe there might be, you have the bye week and that actually helps you over the next few weeks immediately after the bye.
We have one question over here.
I was just curious, you mentioned like the mini bye that comes after Thursday Night Football, but usually a team would have a much shorter week going into Thursday Night Football. So did you notice any kind of canceling out effect between those two? Like a team would have a shorter rest going into Thursday Night Football and that would balance out the longer rest they get after a Thursday Night Football game?
Yeah, it's a good question. It's quite hard to account for that. And I'll say this, when on every Thursday Night Football game, the 2 teams playing in that game will have equal rest. So for the game itself, like both the teams will meet on the Sunday. So neither team in the Thursday Night Football game will have an advantage. In terms of maybe, okay, like you had 3 days of rest before your Thursday game, and then you kind of get extra days to sort of recover. It's hard to sort of see what that effect would be because you can't sort of measure those 2 independently. It's not like we have a Thursday to a Sunday and then we can sort of see the performance differences there. So it's a good question, but I don't know if there's a good way to sort of measure what that might be.
Ron, you have a question this time.
Yeah, we'll do this one and then.
Yeah.
So thank you for the presentation. I just have a question about data selection. So I see that the data was broken down from 2002 until 2010. So is there a reason to just select the first 8 or 9 years as the sample data and the rest as the testing data set?
Yeah. So the reason why we did 2002 to 2010 was because Houston Texans became the 32nd franchise in 2002. If we were to go prior to that, we would have less than 32 franchises, and we could have done that. It just felt like that was a reasonable starting point to just use the data in which all 32 teams that we see today have been playing. So that's why we chose 2002.
We have a question from Steinberg. Sam, can you unmute the room and so we can hear your voice, or whoever wants to ask the question?
Yep, we're ready to go.
Okay, yeah, hi. So you were going after or going over how the bye during the playoffs is more significant than the bye during the regular season. And my first thought was, like, that's obviously true because the bye, like, you earn a bye during the playoffs, right? Like, by definition, you're going to be the better team if you have the bye in the playoffs versus that advantage goes away in the regular season. So I was wondering if you sort of studied the effect of that, how that variable might also be affecting things.
Yeah, no, it's a good question. I would definitely agree if you are a team coming off of a playoff bye, you are more likely to be a better team than just any average team off a bye. I'll note a few things. One, we didn't just look like, if you are a team playing in the playoffs, your opponent's more likely to be a better team than just whoever you're playing. Because if you're coming off a playoff bye, you're also more likely to be playing a better team because that team must have made the playoffs and won at least one playoff game. So you're more likely to be playing a better team. I think I noted that the playoff bye is better today. I think that's maybe what you're referring to, as opposed to in the, like, I don't know if I noted that there was a big difference in the 2002 to 2010. But we also checked other things like against the spread and other sort of metrics that would suggest that, if you are a team with a playoff bye, you perform better. It's not just you have better win percentage because you're the better team, which I think is a good point. But I think we check sort of against the spread percentage and other metrics that would sort of suggest that we believe that it is that there is actually more of an advantage there, or like at least teams have historically had that.
All right, let's thank Tom. Any other questions you can ask him afterwards, but let's round of applause for Tom.